Firstly, we begin with types of chemical reaction. Why we classify chemical reactions into types? Why we need to classify the chemical reaction into types? We have four main types, not all types, but we need to give a scientific reason to this point. We have two scientific reasons. If we classify the chemical reaction, it makes it easier to identify and any similarities or differences between reactions, and it helps us to predict the production that will be formed in any reaction. So we can determine many types, but we have five main types. The first one is synthesis reaction, the second is decomposition reaction, the third is single replacement reaction, the fourth is double replacement action, and for knowing, just for knowing, combustion reaction. This is five types, and we should learn the first four. When a compound is made from simpler substance, we have A substance, it's simple, and B substance, and it's joined together to make or to build a compound which called here AP. I show now some examples of this type of reaction. The combination between sodium, it is a metal, with chlorine as a non-metal, to make an Sl. Here we can see combine or join between elements and elements, non-metal with metal. This is element with element, non-metal with non-metal. Nitrogen is combined with hydrogen to make ammonia. Here, the combine between compounds and elements, like NO combined with O2 to make nitrogen dioxide. And we can see a simple compound combined with a simple compound to make a complicated compound, like a reaction between ammonia and HCl to make or to build NH4Cl. If we have this type of reaction, we can call it synthesis reaction. This is the first type of chemical reaction. The second one, before the second one, I will show for you some example in our life to synthesis reaction. In our life, we can use many substances or many materials that made from plastic. Plastic, we use it in made bag, in toys, in telephone, in some parts of cars, in tube of water, in many materials in kitchen, in our bin, or sometimes our clothes, our bag, sometimes our chair. Many things, many materials in our life are made from plastic. Plastic is made by combine some simple molecule to make a huge or large molecule, like polyethylene. This type of plastic, we made from it bags, small bags. I show some picture to some uses of plastic in our life. This is bottle, this is bags, this is some medical tools, this is some chair. In case of bag, we see 1,000 small molecules like ethene is combined together to make a large molecule which called it polyethene. In our life, we can see proteins, many proteins, and our DNA in our cells are results from combination between amino acids. This is a synthesis reaction. The second one is decomposition reaction. It is an opposite processes of synthesis reaction. It means some compounds is broken down into similar compounds, or some complex compound is decay to simple compounds, like decay of water to give us hydrogen and oxygen. We can type a general form AB, give us A and V. In our life, the digestion of our food is an example of decomposition reactions. Maybe decomposition can happen by heat, and we see some examples. This is mercury oxide. This is copper sulfate. This is ferric hydroxide or iron hydroxide. This is sodium nitrate. This is magnesium carbonate. Maybe decomposition is made by electricity, sometimes, like analysis of water into hydrogen and oxygen, analysis of NaCl into sodium and chlorine, analysis of aluminum oxide into aluminum and oxygen. This third type is single replacement reaction. In this type of reaction, we can see active metals is replace the less active metal in compounds like this. If Fe can replace the copper in this compound and give us FeCl2 and copper, and this is metal replace metal. Atom of metal replace atom of metal. Sometimes we can see atom of metal replace hydrogen. Zn plus 2HCl give us ZnCl2 plus H2. It is happen if this elements is more active than another elements, another metal or another hydrogen. Okay, and general form is to this type is A plus AB give us AC plus P. A is replace the P elements. In double replacement reactions, this is a fourth type. It doesn't matter which is more active, because the positive and negative ions in each two compounds switch places. This take places and that take places. For example, this PSL2 plus NaSO4, we can have Na is place the Pa, so we will have a NaCl, and Pa is replace Na, so we will have a PaSO4. For explain this reaction, I analysis this compounds. We can see that Pa with Cl, Na, 2Na with SO4 give okay, Pa is replaced the Na, and Na is replaced the Pa. This is some examples. This type of reaction may be between acid and basic. like this, NaOH and HCl. It gives us salt and water generally. Maybe aqueous of salt with acid is it is give us aqueous of another salt and acid. Here Na replace H and H replace Na, Na replace H and H replace Na. Maybe between aqueous of solids and aqueous of salt, sorry, like this famous reaction to give us HCl precipitate. In our life, we can see some replacement reaction if our stomach is product more active, more acid, and then we can feel some trouble in stomach. We take MgOH2, some tablet, to neutralize the acid according to this reaction. Mg is replace the H and H is replace Mg, and we will give MgCl2, the acid neutral compound, and H2. The acid is here, it disappears. The last reaction, the last type of reaction, chemical reaction, is combustion. Combustion when will happen if the compound has a carbon and hydrogen, and it is combined with oxygen to give us carbon dioxide and water. This is happen in organic compounds mostly, which contain carbon and hydrogen. Sometimes this type of compounds has oxygen, sometimes nitrogen, sometimes sulfur, maybe. Generally, it reacts with oxygen in combustion reaction and give us energy. This is identify the combustion, a compound containing carbon and hydrogen, which called organic compounds, combine with oxygen gas to produce carbon dioxide and water and a lot of energy. It is happen in petroleum compounds like methane gas. When we compound in O2 to give us CO2 and H2O, we use it to cooking in our kitchen. This is C4H4. This is butane, and oxygen give us carbon dioxide and a lot of energy. Maybe some when we eat food and it will be go to the cells. Finally, the cells is make a combustion reaction to food to have an energy for our bodies and give us carbon dioxide and water again. Like is combustion of glucose, which combined with oxygen to give us carbon dioxide and hydrogen. This is the last example of combustion reaction, and I hope you have a good learning to type of chemical reaction. And thank you very much, and I will see you in another videos or another session. Goodbye.